part 2 of solving trig equations. We're going to now focus on all four quadrants from 0 to 360 degrees or 0 to 2 pi. So here's our first example. We want to solve this equation for x for all four quadrants. So we want to find out when is the sine of x equaling negative 1/2. So before with our calculators we knew we could plug this in like this and we could get an angle measure here. So if you want to just check it for right now, go ahead and put in the sine inverse of negative 1/2. And let's have it in degree mode. And you get negative 30 degrees. All right, but our answer is between 0 and 360 degrees. That doesn't really work in our constraint. So we're going to instead use the unit circle. So let's find out the sine. We're going to go down to degrees first. The sine, remember, is your y values. And we have negative 1/2. So I have negative 1/2 here. I also have negative 1/2 here. So what are those angles? 210 degrees and 330 degrees. Remember our inverse trig, when we plugged it into our calculator, we got negative 30 degrees. Is negative 30 degrees coterminal to 330 degrees? Yes. So our answer in degrees is 210 and 330, or if we asked you it in radians, 11 pi over 6 and 7 pi over 6. So our answers are x equals 7 pi over 6 and 11 pi over 6, or x equals 210 degrees and 330 degrees. For one revolution in the positive direction. Here's a second example. We want to find out what are the values here for x. So we're going to set the two factors equal to 0 and solve for x. So the sine of x plus 1 equals 0. So 2 sine of x plus 1 equals 0. And the cosine of x equals 0. So in the blue we have to do some undoing. So we'll first subtract 1 from both sides. Then we'll divide both sides by 2. Alright, so now let's find the angle, or angles now, since we're in all four quadrants, when the sine is negative 1/2. So negative 1/2, 11 pi over 6. 7 pi over 6. Not just do radians. Then for our cosine of x equaling 0, remember that's our x value. When is the x value 0? It is right here, 1/2, and right here of 3/2, 3 pi over 2. So for our answers in this situation, x equals the sine inverse of negative 1/2. You get x equaling 7 pi over 6 and 11 pi over 6. And for the green piece, x equals the cosine inverse of 0. Those two angles are pi over 2 and 3 pi over 2. There's our answers. All right, this one let's just talk through. I would recommend you write it down, but I have a little bit extra writing on this example so you can work through it. So the tangent of x equals negative square root of 3. And we want to solely use our unit circle. We have talked about plugging it into our calculator, tangent inverse, and you could square root that with a negative, and you get an approximation of an angle in degrees or radians. We don't want you to do that. We want you to use that unit circle. So if we look at our quotient identity right here, the tangent of theta equals the sine of theta over the cosine of theta. We have to find out where do we get the tangent of x equaling negative square root of 3. Well, these kind of take a little bit of time because you have to find some of those ordered pairs and we have to divide them. So I've saved us some time here. This is your x value, this is your y value, or your cosine and your sine. And I picked up this ordered pair. Off to the side, let's just divide this quickly so you can see the square root of 3 over 2 divided by negative 1/2. Should I get negative square root of 3? So you say square root of 3 over 2, flip it, and change it to multiplication. These two cancel, you multiply across, you get negative square root of 3. That's what you wanted. So on our unit circle, where do we get that ordered pair? So down here at 2 pi over 3 and at 5 pi over 3. You have this ordered pair right here and this ordered pair right here. So your two answers in radians are 2 pi over 3 and 5 pi over 3. If you want it in degrees, then it'd be 120 or 300. All right, next example. The tangent of x equals negative 3. All right, tangent of x minus 3 equals 5. We want to solve it for x. So we're going to undo that minus 3 first. So we're going to add 3 to both sides. The tangent of x equals 8. They can't do it like the last problem because there's no ordered pairs on our unit circle that we can go ahead and find it. So let's use our calculator, make sure we're in degree mode. So x equals tangent inverse of 8. And let's see what kind of answer we get. And we get 82.87 degrees. So I want to show you something here on my graph. Here would be 87 degrees for theta. We'll call this theta 1. Is there another place that you're going to get the same value? So you're looking at a positive number for our tangent. Where else on the unit circle do you get a positive tangent? That is down here in quadrant 3. So if I take and add this much more degrees, what is that straight across? Probably it's a little bit better of a drawing line. You have to add another 180 degrees to get that place. So to find theta 2, sorry it's so messy here, right here in the green. So to find theta 2, the other angle between 0 and 360, you're going to take theta 1 plus 180 degrees. So our first angle we said we found with our calculator of 82 degrees. And then plus another 180. Is 262 degrees approximately. So that is our other answer for x. Next example, 3 secant squared of x minus 2 equals 2. We haven't done any of those inverse functions yet, so let's solve this for x. So 3 cosecant squared of x, add 2 to both sides. We have 3 secant squared of x equals 4. And we're going to divide both sides by 3. And if you think about your cosine, that's the reciprocal for your secant. They're reciprocals. All right. So we have to, before we can use our calculator, I'm going to go ahead and change this to 1 over the cosine squared of x. And this is 4/3. And if you want to square root it, to undo it, you get plus or minus 1 over the cosine of x. plus or minus square root of 4/3. And then if you want to flip it, you'd have to flip the left and the right. So now you get 3/4. All right, so what we're going to do next is we're going to do inverse trig with our calculator. And we'll just have it in degree mode again. So we want to take the cosine inverse of square root of 3/4 and cosine inverse of negative square root of 3/4. So we're using our degrees. Cosine inverse of the square root of 3 divided by 4. Finish off that parentheses, and you get 30 degrees. And the other one, cosine inverse of negative square root of 3 divided by 4, and you get 150 degrees. All right, so I want to show you these two places here. So the cosine of 30 degrees, or answer 30 degrees, and then 150 degrees are our two places. Do we have two more places that we get a positive cosine and a negative cosine? Right here and right there. They're the same order pairs, right? These two and these two. So we have two more. 30 degrees and 330 degrees. And 150 degrees and 210 degrees. So our four answers for x are right there. All right, last example. The sine of x equals 2. So let's go ahead and plug this into our calculators, make sure we're in degree mode. We can't find it on the unit circle. So degree mode, go secant sine of 2. And what happens is you get this little notification, probably says something like error or error domain does not exist, something like that. Your domain restrictions for your trig functions for sines and cosines, secants and cosecants for sines and cosines have to be between -1 and 1. So there isn't an answer to this equation. You can't find it. So sometimes, it's not very common in our homework problems, but there are a few times that we throw these at you. You have to understand that your domain has to be between -1 and 1. Think about your unit circle. And when we graphed our sine function kind of goes up and then back down. Here's 1 and here's -1. This is your x, your domain. We don't go any higher than that.